Question number 86. A biomolecule contains 2% magnesium by mass. The minimum molecular mass of the compound is. If I talk about that compound in which magnesium is present, this biomolecule it is, and in this case 2% magnesium by mass is present. It means at least one molecule of magnesium should be there, and the mass of that magnesium molecule is 24U at least should be there, and we know that the percentage of Mg in this compound is 2%. And if we want to just find out the total molecular mass of the biomolecule, because the question is to find out the minimum molecular mass of that biomolecule. So that can be found out by simply considering that percentage of magnesium is equal to weight of magnesium divided by the total weight of the biomolecule that you are taking. And just multiply 100. We know that this percentage is 2%. That's why I can place in this way. So this 2 should be equal to the weight of magnesium. It should at least be 24. Multiply 100 to it, divided by total weight of biomolecule. So what would be the total weight of biomolecules? It would be equal to 12 into 100. It means 1200 U. If the minimum weight of magnesium is 24U, then definitely the minimum molecular mass of biomolecule would be 1200 U. So on that basis, option 1 is the correct answer. And now it's a turn for question number 87. The correct statement among the following is, all the lanthanoids are radioactive elements. This is not true, because only promethane with the symbol PM is radioactive, while other are non-radioactive. Further, the second statement, lanthanide contraction is the accumulation of successive shrinkage. Contraction, you know that this is correct, because this is the contraction due to the filling of 4f orbital before 5d orbital, and this is the correct statement. Further, third statement, actinoids have +4 as most common oxidation state. This is wrong, because in case of actinoid, +3 is the most common oxidation state. And after that, all lanthanoids are very hard metals. No, lanthanoids are considered as soft metal comparatively. So on that basis, option 2 is the correct answer for question number 87. Let's take question number 88. Question number 88. For the reversible reaction, NaNO3 in solid state is here. It's getting changed into NaNO2 in the solid state, and half O2 is released. This is the decomposition reaction, and we know that for the decomposition reaction we have to provide energy. It means this is an endothermic reaction. Very first thing. Equilibrium is there. Now let's see. Further it is said the equilibrium shifts in forward direction. It means you just want to make more amount of product. You just want to shift this equilibrium in forward direction. Then how you can do that? By decreasing temperature. See, this is endothermic process, and if this is endothermic process, if you increase temperature, the reaction will shift in forward direction. But if you decrease the temperature, it starts to go in backward direction, because we know that as per Le Chatelier principle, if you cause a certain change in equilibrium, then equilibrium will shift in that direction so that it can counteract the change that you have done. So in this case, endothermic process it needs energy, and if you decrease the temperature, it starts to go in the backward direction, not in the forward direction. That's why it's not possible. Further, by increasing the pressure of reaction vessel. By increasing the pressure, reaction will go in that direction in which pressure is reduced. It means number of moles are less. So if you increase the pressure, the reaction will move in that direction where the number of moles are less. So in this case also, you will see that in reactant side only 1 mole is there, while in case of product side there is 1.5 mole. So if you increase the pressure, reaction starts to move in backward direction. So this is also incorrect. Further, by adding NaNO2, you are adding a pure solid. Changing amount of either pure solid or liquid does not shift equilibrium in any direction. So this is also wrong. After that, by increasing the volume of reaction vessel. If you increase the volume of the reaction vessel, it means there is the less pressure. And as the pressure is reduced, then reaction will move in that direction where number of moles are more. So in which direction number of moles are more? We already discussed. In case of reactant side, less number of moles are there. At the side of product, more number of moles, 1.5 mole of products are there. It means reaction starts to move in forward direction. So the only case where the reaction will move in forward direction is given in option 4. So option 4 is now my correct answer for question number 88. Let's take second last question. A metal crystallizes in BCC. As it crystallizes in BCC, one thing is very much clear, that Z value in this case is 2. Further, if the diameter of metal is 200 picometer, one more thing, this is the diameter, that is 200 picometer. It means if I talk about radius, it becomes 100 picometer. Now, the question is, then the edge length of the unit cell is. It means in this case, we need to find out the edge length. We know that root 3a is equals to 4r. This formula that I'm just going to use here to find out a value. So what would be the value of a? It becomes 4 into r. R is 100 divided by root 3. The value of root 3 is 1.732. You know that. And if you solve this further, you will find out that this value is 230.95 picometer approximately. And where this answer is given, it's given here in option 3. So let's choose this as our correct answer. Now, it's a turn for the last question of our paper, question number 90. Choose the incorrect statement among the following. Zeolites are biochemical catalysts. This is absolutely incorrect, because if I talk about this statement, zeolites are aluminosilicate minerals. Further, coenzyme increases the catalytic activity of enzymes. This is true. Coenzymes are non-proteinaceous compounds that is necessary for the functioning of enzymes. Further, in Haber's process, molybdenum is used as promoter. If I talk about Haber's process, ammonia is prepared in that. Iron is the catalyst there and the promoter is molybdenum. So, this is correct statement. After that, V2O5 acts as catalyst in contact process for the manufacture of H2SO4 sulfuric acid is prepared by contact process, and yes, V2O5 is act as catalyst. That's why only one incorrect statement is here in question number 90. So that is option 1, and that becomes the correct answer for our question number 90. I hope all the questions those we discussed are clear to you. All the best for your results. Thank you so much.